Hello everyone, in this video we will be reviewing addition and subtraction. We'll begin by remembering all the things that we learned about how to do addition and subtraction throughout the year, and then we'll talk about a method that is a little different that you don't have to use, but it's much faster if you want to use it. So, the method we already know is, let's say we want to do 9 plus 5, right? Well, what we say is, I'm going to put the bigger number in my mind, so 9 in my mind, and 5 on my fingers. And then I would count 5 forward from the number in my mind. So I'd say 10, 11, 12, 13, 14, right? So 14. And that's the same thing with subtraction. So let's say I wanted to do, for example, 8 take away, let's say 4, right? Well, here again, we put the bigger number in our mind and the smaller number on our fingers. So 8 in our mind and 4 on our fingers. We count 4 backwards because we're subtracting now. We need to go backwards. So I would say 7, 6, 5, 4. So the answer is 4 here. So these are the methods that we already knew and we know how to use. But there is another way. Now you don't have to use this way. If you find it too difficult or confusing, you don't have to do it this way. You can stay with this, but if you can and you want to, it's much, much faster, given enough practice. To do this, however, there are some things that are necessary. So first of all, you need to remember the number pairs of 10. So that would be 1 plus 9 makes 10, right? 2 plus 8 makes 10. 3 plus 7 also makes 10. 4 and 6. 5 and 5. And then these just in reverse. So 6 and 4. 7 and 3. 8 and 2. 9 and 1. So if you remember these, 1 and 9, 2 and 8, 3 and 7, the order doesn't really matter in addition. So if you remember these, you don't have to really remember these. You know the first 4, you know the last 4. But you also have to, in order to use this method that I'm going to show today, you're going to have to know the number pairs of the numbers that are smaller than 10 as well. So for example, 3 can be broken up into 2 plus 1, right? Or 1 plus 2, but that's the same thing. 4 can be broken up into 3 and 1, or it can be broken up into 2 plus 2. I'm also not counting 0 because, so 0 and 3 or 0 and 4, this doesn't really matter here. 5 can be broken up into 1 plus 4, or it can be broken up into 2 plus 3, or the reverses, so 4 plus 1 or 3 plus 2. 6 can be broken up into 1 plus 5, or it can be broken up into 2 plus 4, or it can be broken up into 3 plus 3. 7 can be broken into 1 plus 6, 2 plus 5, 3 plus 4. 8 can be broken into 8 plus 7, 2 plus 6, 3 plus 5, or 4 plus 4. Lastly, 9 can be broken into 1 plus 8, 2 plus 7, 3 plus 6, or 4 plus 5. And of course, there's also 2. So you could say 2 is equal to the 1 plus 1. That's something that we all know. So if you can keep these in your mind, these here, or if you can figure them out like really quickly, then you can use the method that I'm going to show now pretty easily. The method is called stepping on 10. Right? And it's based on the fact that we can do additions like, for example, 10 plus 5 very easily and very quickly. It's not as hard as doing, for example, 9 plus 5 or 8 plus 5 or 8 plus 6 or 9 plus 6. Why? Because it has this 10. This 10 makes this addition much easier. I don't have to count anything. I can say 10 and 5 is 15. In Greek, you can even just put the words together. So, dekakepede, dekapede. So you can just put the words together and you get the result without needing to count anything, right? Now, we can use this to figure out additions like this very easily. How? Let's say that we need to do the addition 9 plus 7, all right? Okay, so instead of counting like we would normally, where I'd say 9 in my head and 7 on my fingers, what I can do, and this is normally done in my mind, right? But I can also do it, I can write it down if I want to in the beginning in order to get better with this. And what I can do is say, okay, well, how much does 9 need to become 10, right? And this is where it's very important to remember the pairs of 10. So here you'll see that 9 needs a 1 to become 10. Okay, well, what I'm going to do, and this again is normally done in my mind, but I can do it on paper as well in the beginning. I can say that I'm going to take 1 from 7. I'm going to take 1 and give it to 9 to make it 10. But then what's going to be left of 7? Well, if you remember here where we wrote the pairs for 7, you'll remember that 7 can be broken into 1 and 6. So if I take 1 from 7, right, what I have left is 6. So 9 plus 7 can become 9 plus 1 plus 6. 9 plus 1 makes 10. And then very easily I can say 10 plus 6 makes 16 without needing to count, right? See, this change that I did here, where I turned this addition into this addition, if I can do that in my mind, it can make addition and later subtraction a whole lot easier. But I need to know these number pairs, and I need to know them very well, because you just saw what I did there, where I broke 7 into 1 and 6, right? So let's do some more examples. Let's say I want to do the addition 8 plus 5, right? Okay. I want to do 8 plus 5. Now I want to turn the bigger number into 10. So this doesn't necessarily have to be like this, where the bigger number is first. It could be 5 plus 8. But because it's addition, it doesn't really matter. I just need to have the bigger number turn into 10, right? So what I need to do here is think, okay, how much does 8 need to become 10? And if you look at the pairs, 8 needs a 2 to become 10. So what I'm going to do is take 2 out of this 5 and give it to the 8. But then what's going to be left of the 5? If I take 2, it's going to be left as 3. So 8 plus 5 is going to become, remember, I take 2 out of the 5 and I give it to the 8, and it becomes 10. And what's left of the 5 is just the 3. And then I have 10 and 3, which, if I just put these together, becomes 13. This doesn't always work. I mean, it's not always necessary. So for example, if I'm doing 7 plus 2, you'll see here that when I think how much does 7 need to become 10, 7 needs a 3. Well, I don't have 3, I only have 2. So this number doesn't cross above 10. But if you remember your number pairs, you will remember that, oh, 7 and 2 make 9. So I really don't need to do any more calculations other than that. This technique, stepping on 10, is very useful when we have an addition that goes above 10. This can also be used for subtraction, right? So let me show you how. Let's say I want to do the subtraction 14 minus 8, right? Okay, well, here you can think, how much do I need to take away from 14 to make it 10? Well, I just need to take the 4 away, really. So what I'm going to do is take 4 of these right here, of these 8, and I'm going to first subtract them out of 4. Again, this is something I do in my mind. I don't need to write it down necessarily. So I'm going to take 4 out of the 8 and subtract them from 14, turn them into 10 first. But then what's going to be left of the 8? Well, if you remember your number pairs, you will remember that if I take 4 out of the 8, it's going to be left as another 4. And then I have 10 minus 4, which, if you remember your number pairs from 10, you'll remember that when I take 4 out of 10, what's left is 6. So this is how we learn how to do subtraction. Basically, when we're older and we know these pairs very, very well, this is how we do it. We don't ever need to count forwards or backwards. This is slower than this method, which is much faster. But again, to do it, you need to know the pairs very well. If you feel that this is too confusing, too difficult right now, you don't need to do it like this. You can still count using your fingers. That is perfectly fine. But if you feel like maybe that's a little too slow, then you can do it like this. Then this is a different and much faster method. So that will be all for today, and I will see you guys again in tomorrow's video. Bye.